Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the topic factors on which the resistance depends of chapter 12 electricity of class 10 CBSE NCERT. So for this topic to be understandable, activity is given in the NCERT book which is to be studied for the class 10 students of CBSE NCERT. Okay. So in this activity, a cell is being taken, ammeter is being taken, and the 4 wires are taken of different dimensions. Okay. For the first case, a nichrome wire is taken. For the second case, the nichrome wire is taken but double of the length. For the third case, the nichrome wire is taken but having a high thickness. The thickness is very much more for the third case. That means the cross section area is more. Okay. And for the fourth case, the copper wire is taken. The nichrome wire is kept aside and a copper wire is taken. Okay. So this experiment was being done with the 4 wires of different dimensions for the 4 times. Okay. And for each time, the ammeter reading was being taken. Each time the ammeter reading was being taken and the ammeter reading showed variations. Okay. And according to the ammeter readings, when it showed the variation, we understood how the resistance changes, because we already have seen now the resistance is inversely proportional to the current. Resistance is inversely proportional to the current. V is equals to IR and R is inversely proportional to the current. Okay. So we already know that. So as the ammeter readings changed, that means the current changed in the circuit accordingly. And when the current changed, so the resistance also changed. So on what factors the resistance is being depended? With this activity, it was clear. Now let us see how the resistance is being changing. Okay. So in the first case, a nichrome wire was taken and some of the reading was there, and the resistance, some of the resistance reading was also there. Okay. So as the reading gave, the resistance came. Then in the second, suppose for the first case, the ammeter reading be A and so resistance be R. Okay. So when this was for the first case, we have just assumed it to be the reading to be A and the resistance value to be R. Okay. Then for the second case over here, the length was doubled. The nichrome wire was taken but the length was doubled. Suppose here the nichrome wire was of 10 millimeters. So it was doubled, having, in the second case, it was doubled having 20 millimeters. Okay. So what was the reading effect on the reading of the ammeter? So the ammeter reading in the second case will be equal to A by 2. Whatever the reading was there in the first case, that reading is reduced. The current is reduced to 1 by 2. Okay. That means the resistance will be equal to 2R. So resistance is becoming twice. As we increased the length, the resistance value is also being doubled. Okay. So resistance is depending upon the length. Resistance is depending upon the length over here. Okay. And then in the third case, we are having a wire, nichrome wire, having a higher thickness. Here the thickness is high. When we say a wire to be having higher thickness, that means it is having higher cross-section area. Okay, so area more. So area more. Okay, so when the area was more, then again the ammeter reading was varied. Again the ammeter reading was varied, and as soon as the ammeter reading was varied, means it increased ammeter reading was there, the resistance value decreased. Okay, so the resistance value decreased. So we can say again in the third case, ammeter reading increased. Okay, increased, so resistance decreased. Okay, so resistance decreased. The fourth point will come a little later. So we have made it, we can make the conclusion from here that my resistance is depending directly on the length, but it is inversely depending on the area of the cross section. So it is directly proportional to the length of the conductor, and it is inversely proportional to the area of the conductor, which are my 2 points given over here. So length of the wire and the area of the cross section, how it is depending. It is directly proportional to the length, and it is inversely proportional to the area of the conductor. Okay, it is directly proportional to the area. Okay, so combining these two, we can write it is directly proportional to length and inversely proportional to area. So we can easily write down from here that resistance is directly proportional to the length upon area. So here we are having a proportionality sign over here. When we will remove this proportionality sign, we will get a proportionality constant, which is, we will be getting the proportionality constant. So R will be equal to rho L by A, area. Okay, so this is the resistance formula. Now what is this rho over here? Rho is known as resistivity. Rho is known as resistivity of the conductor. It is known as the resistivity of the conductor, and the unit of rho, when we can take this area over here and we can take this length in the division when it will go on the other side. So my rho formula will be equal to R into area upon length, and the unit of rho is given by ohm meter. Unit of rho is given by ohm meter. It is known as the resistivity. It is known as the resistivity of the conductor. So one thing is sure, resistance is depending upon the length, area and the resistivity. If the resistivity is more, resistivity is the intrinsic property of a material. Okay, it varies from material to material. Whatever the material is there, whether it is a conductor, whether it is an insulator, semiconductor, the resistivity varies from material to material, and as soon as the resistivity varies, the resistance also varies for the material over there. Okay, so it is being seen that resistivity is of the order of 10 to the power minus 8 to 10 to the power minus 6 for the conductors, ohm meters, and for the insulators it is being seen that it is of the order 10 to the power 12 to 10 to the power 17 ohm meters. Okay, for insulators. Okay, Okay, so this forms my third point. This forms my third factor over here. This is my first factor, this is my second factor, and this forms my third factor. Okay, so now it can be easily understood. The fourth, when we place a copper wire, then it is having a different resistivity. It is having a different resistivity, and so when it is having a different resistivity, the resistance also changes for that material. The resistance also changes for the circuit. The circuit resistance changes and the ammeter reading changes accordingly. Okay, when we place forth the copper wire, because till first, second, third cases we were using the nichrome wire, which was having some other resistivity. So as soon as we place the copper wire over here, the resistivity also changes. Because the resistivity changes, so the ammeter reading also changes. So now we understood all the 4 points of the activity of the experiment which is given in the textbook. Okay, so the fourth point, the fourth factor. So fourth factor is the temperature. Now let us discuss about the temperature, how temperature is being depending upon the resistance. How the resistance is depending upon the temperature. Actually, we should say like this. We should say that how the resistance is depending upon the temperature. So it is for the different materials, it is for different cases. Okay, so first of all, let us talk about the conductors. Let us talk about the conductors. How the conductors, the temperature dependency is being there for the conductors and the insulators and semiconductors, how it is for them. Okay, so for the conductors, in the conductors actually, if we see a conductor, there are electrons moving, and if we connect it to the circuit, electrons start moving it. So there is more of the conductivity, and so the resistance value is very much low over there, because the conduction is very much high in the conductors already. So when we increase the temperature, the electrons start moving, bombarding to each other very much. They get highly exaggerated due to the temperature increase, and so the collision rate is very much high. As soon as the collision rate is high, they get collided with each other, and there is an obstruction in the flow of current. So as the temperature increases, the resistance value also increases for the conductors. And so when the resistance value increases, the current rate of flow of current decreases. Okay, because the resistance is the opposition in the flow of electrons. So it is in the opposition for the flow of current also. So as the electrons increases, as the electrons bombarding increases, the collision, the restriction in the movement of the electrons also increases. And as the restriction increases, the current decreases. Okay, so the current decreases. So for the conductors, they are having positive coefficient. They are having positive temperature coefficient. Okay, so all the conductors will be having the positive coefficient, and their resistivity will be increasing. The resistivity will be increasing. So the resistance will be increasing and the current will be decreasing as soon as the temperature is increased. So let us note down the point. Okay, so here we are with the fourth factor. The fourth factor is the temperature. The fourth factor is the temperature. The fourth factor is the temperature. So as the temperature increases, the collision of electron increases. Hence, resistivity increases and current decreases. Okay, one more point is there. It is for conductors. I'm writing over here. It is for conductors. Okay. Yeah, they are having positive. This is the first point. Second point, having positive temperature coefficient. Okay, having the positive temperature coefficient. So if we draw a graph, there is no space left actually, but if we draw a graph between a resistivity and temperature, if the temperature is taken in Kelvin and it is taken in ohm meter, then the graph will look like this somewhat. Okay, it will be looking like this somewhat. Okay, so with this graph it is understood that they are having positive temperature coefficient. Now for the insulators, and semiconductors. Okay, so for insulators and semiconductors, both are having a energy gap in between the valence band and the conduction band. Okay, in this case of semiconductors, the gap is little bit less. In the case of insulators, the gap is very much high. So as soon as the temperature increases, the electrons jump from the valence band to the conduction band, and the conduction starts. And the conduction starts over there. And as soon as the conduction starts, what will happen? The resistivity or the resistance will decrease, and the current will start flowing immediately, and the resistivity will decrease. So how resistivity is depending for the insulators and semiconductors? The resistivity is being decreased and the conductivity is being increased. Now what is conductivity? Conductivity is the reciprocal of resistivity, and the unit of conductivity is given by mho. It is given by mho, mho. Okay, so let us write the point. The point is that as the temperature increases, the resistivity decreases and conductivity increases. Okay, why conductivity increases? Because electrons jump from the valence band to the conduction band and they start conducting over there. Okay, in the case of insulator and semiconductors. Okay, so the second point is that they are having negative temperature coefficient. They are having negative temperature coefficient. And if we draw a graph, it will look somewhat, it will be similar for the semiconductor and insulator. Somewhat it would be similar, and it would be look like this. I'm just drawing over here because it will be showing the negative temperature coefficient. Okay, this is the temperature given in Kelvin. Okay. Now there are some special materials also. They are known as superconductors. So what are superconductors? We will quickly see over here. Superconductors. These are important for the exam point of view. So superconductors are the materials having zero resistance at extremely low temperatures. The temperature is so much low from, you can imagine, from -100 degrees centigrade to minus 150 degrees centigrade, minus, so much extremely low temperatures. So at extremely low temperatures, some materials have zero resistance. So the materials having the zero resistance at extremely low temperatures are known as superconductors. And the most relevant example of this superconductor is mercury. Okay. So let us write down the definition. They are having materials having zero resistance at extremely low temperature. Okay, example, mercury. Okay, so in this session we have understood what are the factors on which the resistance is depending. So the factors on which the resistance depends is the length of the wire, the area of the cross section, the nature of its material, and the fourth is the temperature. So there are four factors very much important from the exam point of view. They can be asked in the question of the 4 marks also. It can be asked in the 2 mark question also, and also the formula R is equals to rho L by A can be asked, the numericals can be asked from this formula also. So this topic is very much important for the class 10 students. Okay, so this was all for today. So in the next session we will be dealing with the resistances in the parallel and the resistances in the series. So till then, goodbye. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.